The mountaintops rumble to life unnaturally each year as snow clouds darken the sky across the west. Open flames burst from the throats of metal chimneys, mounted on squat towers nestled among the peaks. With a low hiss, puffs of particles belch from their mouths into the air, where the wind catches them and whisks them away. These aren't ordinary particles. They're tiny bits of crushed-up silver iodide, a crystal-like photosensitive substance once used in photography. But it's not used to take pictures out in the mountains. It's meant to make snow. As the wind whips the particles across the mountaintops, drafts of air sweep them higher into the sky, so high that some of them eventually touch the clouds. There, an elegant transformation takes place. The crystalline silver iodide particles have a structure similar to ice, and inside a cloud, like attracts like. Water droplets begin to cluster around the particles, freezing solid as they gather together. These frozen clusters eventually grow too heavy to stay in the air. They fall from the cloud and drift gently toward the earth, dusting the mountaintops with fresh snow. This is not a page from a science fiction novel. Cloud seeding is a real practice. In fact, it's been around for decades. It's used today to boost precipitation in at least 8 states across the western US and dozens of countries around the world. Interest in cloud seeding is growing as temperatures steadily rise, increasing drought risks in places like the Mountain West. But there's a catch. Scientists aren't sure how well cloud seeding works today, let alone in a warmer climate. Amid growing concerns about water resources in the western US, scientists are working to answer those questions. Today, cloud seeding research represents the cutting edge of weather and climate science, a convergence of questions about the influence of warming on our dwindling water resources and our ability to control those consequences. Certainly, we're in a better position now to address that question than we were 10 years ago, said Jeff French, an atmospheric scientist at the University of Wyoming. The state of the science has progressed to the point that it is a question that we can and should be trying to address now. Cloud seeding can take a few different forms. In some places, it's used to boost rainfall or prevent hailstorms. But in the US, it most commonly aims to enhance snowfall, and usually with silver iodide. Extra snow can be a boon for water resources, especially in places like the drought-plagued West. Snowpack is a vital source of fresh water for millions of people across the country when it melts in the spring. Boosting snowpack is being pursued with growing urgency. Much of the western US has been gripped by drought for the last 20 years. Scientists recently concluded that the past 2 decades represent the driest span in the region since at least the late 1500s. This megadrought has been heavily influenced by climate change, they found. Rising temperatures and the ongoing drought have taken a major toll on western water resources. Recent studies find that large patches of the Mountain West have experienced major snowpack declines over the last few decades. ClimateWire, December 13, 2018. The snow season is also growing shorter as the climate warms and spring gets an early start. Meanwhile, Western water managers are contending with the growing threat of shortages. Flow has dwindled on major water systems like the Rio Grande and the Colorado River, which each supply water to millions of people. With temperatures steadily rising, cloud seeding poses one attractive solution. Water managers basically have 2 choices, and both of them are implemented, said French. One is to somehow reduce the demand through conservation, and the other is to somehow increase the supply. And cloud seeding is a relatively inexpensive proposition. Proving that it works, though, is another matter. Weather experiments are notoriously difficult to conduct. The scientific gold standard would be a study that proves cloud seeding produced an outcome that definitely would not have happened without it. But that kind of research requires a combination of specialized experimental design and highly advanced technology.
Which they claim they've been doing for decades. But yet, we're in the biggest mega drought for the last 2 decades. Maybe what you've been doing ain't been working. You think?
Technology. For most of cloud seeding's long history, it just wasn't possible. Only within the last few years has technology advanced enough for researchers to really dig into the problem. We now have much better tools to try to observe cloud seeding as it's happening, French said. So it's sort of about taking this new technology that has been developed over the last 20 years, or improved upon over the last 20 years, and applying it to really a very old problem. Decades of questions. Humans have been experimenting with weather control for the better part of the last century. Vincent Schaefer, a researcher with General Electric, is often credited with the first cloud seeding experiments in the 1940s. Much of Schaefer's work during and after World War II centered on preventing aircraft from icing over in midair. So he designed a special homemade freezer to help him better understand the way ice forms inside clouds. As the story goes, Schaefer entered the lab one day to discover that his freezer had been turned off. Hoping to cool it as quickly as possible, he placed a block of dry ice inside the box. A cloud of glistening ice crystals instantly formed in the air. In 1946, Schaefer conducted the first true cloud seeding experiment by aircraft. He dropped 6 pounds of crushed dry ice into a cloud in the Adirondack Mountains of New York. Almost immediately, snow began to fall. In later experiments, Schaefer and other GE colleagues would discover that certain types of particles are more effective at helping ice crystals form. Silver iodide, they found, is one of the best. Weather modification quickly captured the attention of the US government. Over the next few decades, it would fund cloud seeding experiments on everything from drought management to military applications. In 1947, Project Cirrus, a collaboration between GE and the US military, made history as scientists' first attempt to modify a hurricane. On October 13th, the operation dumped nearly 200 pounds of dry ice into a cyclone that was churning off the coast of Florida. In the 1960s and early 1970s, the federal government continued to experiment with the idea of cloud seeding hurricanes, but to little avail. Scientists eventually concluded that it wasn't effective. Beginning in the early 1960s, the Bureau of Reclamation funded a series of cloud seeding experiments known as Project Skywater, aimed at boosting water resources in the western states. Reports suggest the project had mixed results. In the late 1960s and early 1970s, the US military even experimented with weather modification as a weapon of war. Operation Popeye, as it was dubbed, aimed to generate enough rainfall to disrupt enemy supply routes in Vietnam. These efforts were short-lived. In 1977, an international treaty banned the use of weather modification for military purposes. There was a common thread among many of these early experiments: either they weren't useful, they were quickly discontinued, or scientists couldn't tell how well they were working. There was a ton of research done in the 60s and 70s and 80s, said French, the University of Wyoming scientist. But all of that kind of came to a halt when I think there was a realization that agencies were spending millions upon millions of dollars year after year, and the results continued to sort of be inconclusive. The problem, he said, is that weather modification studies are really difficult to design and carry out. To prove that cloud seeding has a real effect, scientists have to demonstrate that whatever outcome it produces would not have happened without it. That requires setting up an experiment with at least 2 tests, one with cloud seeding and one without it, in the same location and under identical weather conditions. Because the weather changes so quickly, that's really difficult to do. And even when it's possible, such studies require advanced monitoring technology, including high-tech radar. This kind of tech just wasn't widely available until recently. That means cloud seeding research has mainly relied on statistical studies instead. These studies measure the precipitation produced with cloud seeding in one location, and then they compare it to a different location where no cloud seeding took place. The 2 settings aren't identical in these kinds of studies. That means they don't definitively prove that the precipitation produced by cloud seeding in one area would not have happened without it.
Which means the studies are flawed right from the start. Before they even start them, their studies are flawed because of the variables.
In 2003, the National Research Council published a comprehensive report on weather modification, highlighting these problems. It concluded that there is still no convincing scientific proof of the efficacy of intentional weather modification efforts. Still, NRC recommended continued research on weather modification, in no small part because of its potential to address the West's worsening water concerns. That same hope has led state water agencies to keep funding cloud seeding operations, even after federal research efforts dropped off in the 1980s. I think there's a pretty easy explanation for why it continued, French said. Cloud seeding is rooted in a pretty solid, well-understood physical basis of why it should work. States embrace uncertainty. Today, cloud seeding operations take place in at least 8 states across the western U.S., with varying levels of investment often shared among state agencies, utilities, and private companies such as mountain resorts. Cloud seeding programs in the upper Colorado River Basin, for instance, cost around $1.5 million each year. The costs are split among state agencies in Colorado, Utah, and Wyoming, where the majority of the operations take place, as well as Nevada, California, New Mexico, and Arizona, which also stand to benefit from increased flow on the Colorado River. In the last few years, cloud seeding has featured more prominently in drought management strategies across the West. The cost-sharing agreement in the Colorado River Basin was finalized in 2018, after states had spent years individually managing their cloud seeding operations. The agreement extends through the fall of 2026. Since 2018, Wyoming and Colorado have strengthened their programs by investing in aerial cloud seeding operations, that's seeding conducted by aircraft, in addition to the ground-based machines they already have scattered throughout the mountains. These are relatively inexpensive investments, all things considered, a low risk for a potentially high reward. But is it actually making a difference? Most programs point to statistical studies to justify their efforts. These studies indicate that seeded clouds can produce around 5% to 15% more snowfall compared with areas where no cloud seeding took place.
Now, compare that to the number of people that have respiratory issues and people having issues with their lungs and breathing problems because of having to breathe in these particulates. Is it really worth 5 to 15% more snowfall at your snow resorts?